All right, I know you're going to be really excited because today we have word problems, which I know are just everybody's favorite. So, all word problems are going to be a little different. And in this particular section, at the beginning of the school year, they're just trying to get you familiarized. There's not, all the word problems are the same type, which means you're going to have to rely on some previous knowledge as well as critical thinking skills in order to solve them, because I'm going to give you some examples here, but not everything that you see in your practice problems or exit tickets or anything like that are going to be just like these ones. You have to use those thinking skills because word problems are what, you eventually end up doing in real life. So, first one, Maddie can ride her skateboard 4 miles per hour. Her friend Alicia's house is 2.5 miles away. Write an equation that can be used to find m, the number of minutes it will take Maddie to get to Alicia's. So we've got a couple things going on here. We're talking about traveling, speed, distances, all of that. And so a previous knowledge that we're going to need to use here is our rate times time equals distance. Now, I've seen this equation taught a bunch of different ways, and I know in science they use velocity instead, which is fine. If you have an equivalent form of this, that's fine. I've seen a lot of people who have it memorized as rate equals distance divided by time, which is the exact same thing. So that doesn't matter. If you set it up a little bit differently, that's no big deal. So that's one thing that we need to know in order to be able to actually write this one variable equation. The other thing that we really need to be careful of is anytime we have something with rates and labels is that you need to pay attention to the units. Here we have some units that don't match because it wants to know how many minutes it's going to take, but our rate is given in hours. Now the distance is okay. This is miles and this is miles. So we just have to do one conversion. But this is our rate, the 4 miles per hour. This is our distance, the 2.5 miles away. What we're trying to find is the time, the number of minutes. But we have to convert our rate so that it has the correct label. We don't want hours. So right now, here's what we have. 4 miles in 1 hour. And if you just know how to make that into miles per minute, you can go right ahead. You don't have to show this work if you just know the answer. But typically the way that I know they've taught it in middle school and junior high is that you multiply by your conversion factor. And the way that you know which direction, like we know we need hours and minutes, and hopefully you know that conversion value, but the way you know which one goes on top is by which one you need to cancel and which one you need to stay. We want hours to cancel out, which means that since hours is on the bottom here, it needs to be on the top over here. So 1 hour, what I need is minutes. Hopefully we knew that 1 hour is 60 minutes. So this is our conversion factor. It's equal to 1, which is why we're allowed to multiply it. It's not changing the value, it's just changing the format. So these will cancel out, and that gives me 4 miles per 60 minutes, which, if I reduce that, because 4 and 60 are both divisible by 4, that gives me 1 over 15. And this is in miles per minute. So my rate is now 1/15th instead of 4. So now that I've converted that, I can write my equation because I'm going to put that in for my rate. So 1/15th, you don't have to put in the labels in the equation, times time, which is what we're looking for, and it says to use m as the number of minutes, equals the distance, which we're told is 2.5. Now, because this is a real life situation, you're allowed to use a decimal. So you can go ahead and use a decimal here if you'd like. If you would prefer the fraction, that's totally fine as well. So here's our equation. We could use to solve for m, which is what it asks us to do in the very next step. So if I want to get m by itself, that means I need to get rid of this 1/15th, We get rid of fractions by multiplying by the reciprocal. So when I have this 1/15 m, I'm going to multiply by the reciprocal, which is 15. It's 15 over 1. So whatever I do to one side, I also do to the other. So these are going to cancel, and m is going to be alone. And so then on the right side, I just have to do the 2.5 times the 15, which will give me my final answer, which is 37.5. And remember that our answer was in minutes. All right, hopefully that didn't seem too terrible. Sometimes you won't have to do conversions. My feeling is I always try to do things that have a little bit of trickiness together, so hopefully the ones that are less tricky you're able to do on your own. Next one, a water park has a new water ride called Dueling Downspouts, where riders on 2 tube slides race each other. So these are riding simultaneously. The table below summarizes key information for each slide. So it gives us which slide it is, how many riders go on the tube, and then how often they can release those tubes. So there are 100 riders total. R of them are going to take slide 1. And we want to write an expression to represent how many riders take slide 2. Now, key thing here, this says expression. Expressions do not have an equal sign. Equations have an equal sign. So we do not want an equal sign here. If you just know the answer, that's awesome. Write it down. If you don't, one of the strategies I wanted to go over in this video is how to deal with if you're unsure of what to do with the variable. So one great strategy for word problems is to pretend like you know the value of the variable and see what you would do if you did. So if I said if there are 100 riders total, 40 of them take slide 1, how many take slide 2? I think all of you could answer that, because I think that my own kids could probably answer that, and that would be 60. And so you question yourself, okay, what did I do to get that answer? Well, I took 100 and I minus 40. So you do the exact same thing with the variable, because 40 was made up. It was a replacement for our r. So 100 minus r is how many riders take slide 2. So we have r riders for slide 1. We have 100 minus r riders for slide 2. And we have 2 riders per tube on slide 1, 4 on slide 2, and different release times as well. Assuming that all tubes must be full, write an equation that you could solve to find out how long it takes all 100 riders to go down the slide. So let's start with slide 1. If I have r riders and there are 2 per tube, I can release a tube every minute. That doesn't mean I'm releasing 1 rider every minute. That means I'm releasing 1 tube. So technically I'm releasing 2 riders every minute. So number of riders divided by 2 would represent the number of tubes times 1 tube every minute is going to represent how long it takes for that first slide. Now, these are running simultaneously. So we're setting it equal to the similar expression for slide number 2. So I want you to pause this video real quick, try to do the right side of the equation in a similar fashion using what you see in the table here for slide 2, and then unpause it to check when you come back. Okay, so hopefully you have an idea here of what you need to do. This is what I came up with. Because 100 minus r is the number of riders for slide 2. We divide that by 4 because 4 of them at a time. So this represents the number of tubes. Multiply the number of tubes by how often you can release it, which is 1.5 minutes, and that gives us our total time for slide 2. So when slide 1 equals slide 2, that means that we can solve it. Now, it doesn't say to simplify the equation, so you don't have to. but I'm just going to show you what it would look like if we did. So r over 2 times 1 is just r over 2. Over here, you could simplify a bunch of different ways, but I would probably just multiply top times top, bottom times bottom. So 100 times 1.5 is 150. 1.5 times negative r is negative 1.5r. And then on the bottom, 4 times 1 is 4. And so this would be a simplified equation. Last thing for this video is to actually solve this guy. I think the easiest way to do that is to cross multiply here because it's written like a proportion. So r times 4 is 4r. 2 needs distributed over both of these, so that gives us 300 minus 3r, which now it looks like a pretty simple equation to solve. Add our 3r to both sides, so 7r equals 300. And then divide both sides by 7. It doesn't come out evenly, which is fine. You get like 42.857 something. We want to write our answer in a way that makes sense. So the question asked how long it takes all 100 riders to go down. So I would just say about 43 minutes. Of course, if it specifically asked you to round to a certain point, we would. This one didn't, so we just leave it at that. All right, hopefully that makes sense and you are set to go ahead and do your practice problems.